All right, cool. Hopefully you watched the intro video so that this makes a little bit more sense. Remember from the intro video, the idea is that we are going to be doing graphs of lines. And that's exactly what a linear function is, okay? When it says interpreting linear graphs and y equals mx plus b, the idea, guys, is that a linear function, notice the hidden word line, it just means that there's a relationship between the points, okay? You're going to have a bunch of points, blah, 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 okay? And whatever these points are, when you actually graph them out, they will form a line. Okay, and maybe the line is going up this way. Maybe the line has points that are actually going down instead. And then there's also lines that can go completely horizontal or completely vertical. That's also a possibility. So what we're going to study today is, instead of having to find all the points on a graph and go in and do the points and then connect the dots, we're going to try to take the equation that we see, which is right up here, y equals mx plus b. The name of that is actually called the slope-intercept equation. There we go. That's the real name for it in the math world. We're going to learn what this means, okay? The idea here is that the y, when we see an equation, the y will be a y, the x will be an x, and those would be like our points that are over here, okay? But the m and the b, those are two, right now they look like variables. There will be numbers in the spot of this, and there will be a number in the spot of this, okay? So an example is, you might see something like y equals 2x plus 3, and so there'd be a number for that, a number for that, that'll stay an x, that'll stay a y, and we're going to learn how to take this, and instead of making the chart, we're going to just like be able to do the graph from the equation. Okay, so that's the goal. Now let's talk a little bit about slope first, the types of slope. This kind of relates to what I drew up here, okay? Whenever you're reading slope, you want to read slope like a book, okay? Read slope like a book. And what that means is, when you read a book, you go from left to right. Okay, so when we're reading the lines of a book, we go left to right as we're reading the words. That's how you want to read slope. Now, if you look at your line and it's going up from the left to the right, if it's increasing, and you can imagine yourself as a little person walking up a hill, yay, here we are walking up. This is called a positive slope. Okay? Now, anybody want to guess what it would be called if, oops, that's weird. Let me erase that little stupid thing. Okay, anybody want to guess what it would be called if the thingy was going down? So imagine you're walking down this little thing and you're going left to right, so you're walking down the hill or down the line. That would, of course, be a negative slope. And two other, I don't have room in this box right now because I'm dumb, but if I had made a little extra room in this box, we could go over what it's called whenever the line goes completely horizontal or completely vertical, okay? If it's completely horizontal, this is actually called a zero slope, and if it's going up and down, this is called no slope. The slope actually doesn't exist, and this makes sense because you can't walk straight up a cliff. I mean, yes, you could find a way up, but if you're trying to walk like my little people over here, there is no walking, okay? So that's how we talk about slope, is either positive or negative, and we're going to talk about how slope is measured from a graph, okay? So how is slope measured from a graph? Well, what you're first going to need to know is that the way when people talk about slope, it is their steepness of the graph, okay? It's the steepness of the line or the graph that they're looking at. And the way that it is measured is by looking at how much it is growing vertically by how much it's growing horizontally, and kind of comparing those two. So some people call it the rise over the run. You're going to hear that a lot next year. And rise over run is really weird. Rise just means, you know, how much has it gone up or down? And the run is how much it has gone across. And until you see it on a coordinate plane, this doesn't make sense. But let me try to draw it, and then once we talk through it with an example, I think this will make sense, okay? So let's put some little tally marks on here. Let's just do this out to like 4 in each direction. So if you're taking notes, just hit pause and make yourself a little graph that goes by 4 in all directions, and then come back. We're going to put a point at, let's just put a point at the origin, 0, 0, and let's put a point at like the point 3, 2. Okay, so there's my point 3, 2. All right, and if we play connect the dots, then our line would look like this. Okay, now before we actually talk numbers, would you call this slope positive, negative, 0, or no slope? Hopefully you'd call it a positive slope because it's going up. And if we actually want to measure the steepness, which is what slope is, okay, it's also called a rate of change. If you want to know, slope is also the rate of change. It's how steep it is, or how much it's changing, how quickly it's changing. So now that I've rambled enough, how do we actually do this? Well, what we want to do is I always go from left to right, remember, just like a book, and I find 2 points on my graph. And I just ask myself, if I had to get from this point to this point, how many do I need to go up? And then how many do I need to go across? So it's almost like just if you were walking on this coordinate grid, what would you have to do? So to get from here to here, I would have to walk up 2 units. And once I went 2 units up, then I would go over 1, 2, 3 units. So I'd walk up 2 and over 3, and that is how you measure slope. Up 2, over 3. And so the slope would be 2/3. So it's weird because you see slope and it's always a fraction, and you're like, how does a fraction tell you anything about how steep it is? Well, that's how. If you understand that the numerator is your up number and the denominator is your across number, and by across I always go to the right, okay, then that's how you're going to know slope. So it's just counting, which is beautiful. So what we're going to do is I'm actually going to scroll down here, and we are going to do this example before we do that, okay? So let's do this example, then we'll go back up to that other box. So how would you find the slope of this given graph? Well, the first thing that you would notice, hopefully, is that it's going up. Okay, so we're going to look for how many up we need to go, and then how many across we need to go, or to the right. So up and to the right. Pick any 2 points that you want. You can go from this point to this point, or you can go from this point to this point. It really doesn't matter. You just want to count on your grid what's happening. Okay, now on your paper, I'm hoping your grid's a little bit better than mine. My grid is pretty terrible, actually. Let me see if your copy looks any better before I do this, because I might have drawn, I can see a very faint line right here, and so I'm drawing that in. I think y'all already have that drawn in, and there's another faint line right here. So y'all should already be drawn in on your paper, so sorry, mine's pretty terrible. But anyways, let me go ahead and try to count it out. So I'm just going to go from this point to this point, and I'm going to go up. So if I need to go from here to here, I need to go up 1, 2, 3, 4. I need to go up 4, and then I need to go over, it looks like 1, 2, 3. So I'm getting 4/3 as the slope, okay? Now, we haven't seen one yet where the line is going down, but if the line had been going down, then you still do the same thing. You count how many down and how many across, but the difference is that if it's a line going down, notice this word negative up here, you would need to put a negative symbol in front of it. So line going down gets a negative symbol. We'll see one of those later. Okay, now let's come back up here. So that's doing something from a graph. Now, how are you going to interpret slope from an equation? So remember that equation that was written at the top of the paper? And I told you that this would stay a y and this would stay an x, but there would be numbers in these two spots. Well, one of those two numbers is slope. And here's what's pretty awesome to know. This right here is slope now and forever. If you ever see an M in a math class and you're talking about equations, like, it's always going to be slope, and the whole math world calls it an M. So this is not something I've made up. This is the world, baby. So if the number stuck to the x is the slope. Now, this other number over here does have significance, and we're going to do something with it in just a second, but just so you know, let's go ahead and label it now. This random number that's over here is actually called the y-intercept. Now, if you don't know what a y-intercept is, that's okay. I'm going to show you later in this video, but it's good to go ahead and know now what each of these numbers are. All right, cool. So now how is this going to work? Well, based on what we just wrote, if it's telling you, okay, I need you to sketch the linear function y equals blah, 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 blah. Okay, your job is, instead of doing a chart, which is probably what you did last year, where you would do a chart of x's and y's and you'd plug in numbers, we're going to try to do it without the chart. So based on what we did a second ago, mx plus b, if you just compare this to what's above it, well, the m is the slope. So the number stuck right here, the stuck to the x, that is slope. So my m in this problem is -2, and my b is 5. This is just comparing the parts of the equation. Now, you have to understand what that actually means. Now, over here, our slope was a fraction. Up here, our slope was a fraction. Right here, it is not a fraction. But guess what? You know how to make it a fraction because you learned that a long time ago, right? There you go. If it's not a fraction, just stick it over 1, and now it is a fraction. Okay, so if I want to express the slope now, and I'm working backwards, you know, and I'm like, well, what does this mean? Well, a -2, remember, negative means the line's going down. So what this means in words is that the slope is going down 2 and across 1, or to the right by 1. I always go to the right for this bottom number, guys. Always, always. So it means down 2 and right 1. That's my movement that I need to do. Now, this number is super important too. I called it a y-intercept earlier. It is your starting point. It is where you need to put the first point of your graph. It's the starting point, and it's on the y-axis. That is what y-intercept means. Remember the word intercept from, like, well, not just math, but from everything. If you intercept something, you cross it. And so if it's a y-intercept, it's where you're crossing the y-axis. So I'm going to do these out to 5 in all directions. Feel free to do this on your own paper, and if you need to hit pause, hit pause. So if you make a scale, then just like I said up here, this number at the back is your starting point. So I need to start at 5 on the y-axis because it's my y-intercept. 1, 2, 3, 4, 5. This is my first point. In fact, I'll do that in a different color. This is where you put your first coordinate. Now, when you follow the rules of slope, I already wrote out down 2 and right 1. So that's exactly how I'm going to move. I'm going to start here at this point and go down 2. And then to the right by 1, and that's where I put my next point. I'll do that again. Down 2 and right 1. So what should be happening is if you keep doing it over and over, it should form a really nice straight line, assuming that your scale is good. Don't worry, on the homework I gave you guys a bunch of grids, so you're not going to jack it up like I'm doing right now, or like you may have done in your notes. Sorry about that. But you will have a grid on your homework, okay? All right, cool. So that is how you graph a line. And these points that are here, 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 and here, these are the same points that you would have gotten had you done this like you did in middle school whenever you took x's and y's and you made a chart out of them. So in other words, if x is 0 and you had plugged it into the function up here and you plugged in a 0, negative 2 times 0 is 0. 0 plus 5 is 5. This is how you might have done it in 6th or 7th or even 8th grade, okay? If you'd have plugged in a 1 for x, negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. And notice as I'm picking numbers 0, 1, 2, 3, and I'm plugging them into this equation, I am getting the answers that I already graphed right here. They should always match up that way, okay? This will work, I promise you, okay? And do it whichever way you want, but you're going to have to know this way this year. So don't try to rely on just picking points and plugging them in. You want to be able to do it the other way. All right, cool. So the last one over here, find the slope and sketch the graph given that the x-intercept is 3 and the y-intercept is negative 5. Okay, so how do we do this? Well, first we have to know vocab and what that means, and then I'm going to use my graph to figure this out. Okay, so we already talked about a y-intercept, okay? It means that you intercept the y-axis at negative 5. 1, 2, 3, 4, 5. So I'm just going to put a dot down here at negative 5 on the y-axis. Now, based on that, what do you think the x-intercept means? Well, it's the same bloody thing except the other direction. It means we intercept the x-axis at 3. So I need to go to 3 on the x-axis and put my next point. Okay, so beyond that, that's it. I mean, it's given us 2 points, and any time you have 2 points, you can play connect the dots, and you have a straight line. And now it says find the slope of what we've just done and sketch the graph. So we've already sketched the graph, so let's find the slope. So this is just like we did over here. It's the same thing. So we're going to count to get from the left point to the right point. I need to go up 1, 2, 3, 4, 5, and I need to go over 3, 1, 2, 3. Now, does this need to be a negative number or a positive number? Well, it needs to be positive because the line is going up. I went up and to the right, so it stays positive. Only put the negative if you were going down and to the right. All right, hopefully that is enough to get you started, and you can do, I'm hoping at least, you should be able to do at least half of the assigned problems that I gave you. I don't know which half because it depends on what you're good at and what you're not, but don't make it too hard. Like, please follow the video, look back at these notes if you get stuck, and you should be able to do quite well with what you see. We want to get good at this because next week it gets really tricky based on this. It's going to be a lot of working backwards, and you really have to be able to go forwards to be able to work backwards. So good luck, and we'll see you guys in the solution video.